So as we understand that it's a combination of sensing, computation, and communication. While doing developing the projects or products or even research, like I said, characteristics of a successful product also depends on the correctness of the data, capabilities, cost, time. So it might not be possible to have that kind of a infrastructure or collection of the data, huge data, if you are planning for such kind of applications. So new methods are emerged, new industry has come up where people are providing services in Internet of Things. So it has become a very big industry as a service oriented industry. So in IoT, one of the service called things as a service, TaaS. Things as a service means like minimum systems, right? You have developed a customized hardware and software. And if any industry wants to make use of your service, let's say in every town, every village, you have some hardware, and that hardware is meant for measuring some parameters. I am interested only the data. So then I can hire the service, your hardware service. So things as a service. We are not talking about general purpose systems. Unfortunately, even in hardware also, people have come up with these Arduino boards, Raspberry Pi boards. These we have unnecessarily brought into engineering education. They are okay for school education, not in engineering. If you do it, the products by those things, then you cannot patent it, you cannot commercialize it. Nobody will take your service because they are become like a computers, general purpose systems. First thing is anybody can copy it because they're already there, already available in the market. So as a product perspective, you don't find any product which is made by using Arduino boards or Raspberry Pi boards, or for that matter, any hobby, those online available kits, because product means patented. Patent means confidentiality of the design. It's not possible. In academics, if you do a project, what are you trying to do is copy paste the things. The board which you are using, the code which you are using, already available in the public domain. As I said, it is a crime. Forget about the research. In research means actually you are adding the knowledge to the existing knowledge. So beyond what we are talking, the currently available technologies. So that's the reason why when I'm saying services, people take your services only when it is unique. It's not available. People will pay for that service. So hardware is a service. Things as a service means hardware is a service. They will hire your service. Data as a service. So people are collecting the data and they do all this data generation, data collection, data cleaning, data aggregation, data mining. So the data services, maybe small data, big data, DAS. So since I am developing my business model, my application, I may require these services. I'm not in a position to invest on the data collection or data cleaning, data aggregation, data mining, because it requires a huge infrastructure investments. So better hire the service. Some of the services is a shorter period of time. Say for example, if there is an election for the country will be there hardly 2 3 months. So till the next general election, 5 years, I don't need the infrastructure. So I require the infrastructure only for 3 months. So why should I invest where another 4 years and 9 months is not going to be used? Better use a service. So data as a service, things as a service, platform as a service. Now here what happens, let's say for example, Google platform. From Google application we have some APIs, right? Application program interface. Some of the people have come up with some solutions. Let's say the traffic monitoring system, alarming system, weather monitoring system, and so on. The people who are working in solar industry, they want to know last 5 years, 10 years, what is the solar radiation in that particular area so that they can invest on the solar generation, PV, electricity generation by using PV panels. But I require the data before I invest. Is it viable or not? There is a return of investment or not? So then you look for some websites, services where they provide the platforms. I require some real time calculations and so on. So looking at these applications, some people are come up with their own platforms or some protocols in terms of application layer protocols like MQTT, AMQP, CoAP and all. So they provide these protocols, application layer protocols or the platforms or the user interface, dashboard design. You don't need to write the code from the scratch, like a drag and drop it sort of a thing where you can build up your own application quickly by using those platforms. Today, you know, Amazon, AWS, Azure, Google, several companies are providing the services with the help of their own platforms. So you can quickly build up your application by using those platforms. I hope now it is clear to you the amount of business involved in this domain is a $1 trillion industry, but at the same time, you can also develop your own application product by using these services, either things as a service, data as a service, or platform as a service. All right, so now let us look at what is your application you are planning to implement. Since this is about project, product, and maybe a research, looking at your domain, how many layers are involved in your application? In computer architecture, in computer communication and networks, CCN, there are some OSI layers are there because it is general purpose in nature. So they have provided all those layers. However, in application specific, in IoT architecture, not necessary you have to implement all those OSI layers of CCN. Your application may be a small application, your application may be a medium scale application, your application could be a very, say, empire, corporate application. So if it is a small application, then you can start with 3-layer architecture like perception, network, application layer. Similarly, 5-layer, 7-layer, some industrial architectures are available. The minimum architecture is 3 layers, where you can see the first is to begin with perception and computation. Means in IoT domain, the first layer is acquire the data with the help of the sensors in real time. In a natural time, in natural environment, acquire the data and compute the data. That is the first layer, perception layer. Once you acquire the data, then you need to communicate the data with the help of some networks. There are types of networks, so you may require some medium, you require also some protocols to transfer the data, because it's not a standalone system, it's a internet of things, means there is a internet connectivity is involved, and that connectivity not necessarily always internet. It may be a short distance communication, it may be a medium distance communication, or it's a global communication. So network layer, communication layer is involved. After that, once you communicate your data, right, between client and server or network of the devices, then you require the application, right? You may implement the application. So you require the protocols which are meant for communicating the data to the various application layers, application servers, APIs, application program interfaces, like as I said, Google, Amazon, or maybe even this, right, social media platforms. This is the minimum, a 3-layer architecture. So any IoT application, if you are implementing, one has to implement perception, network, and application layer. Do not make any assumptions here. If you miss any one of them, that means you are not doing any product development in IoT domain. Once again, some shortcut methods, as good as like a computer application you are doing, not a IoT application. However, you can also think of 5-layer architecture, where transport layer, processing layer is also involved, or maybe some other 7-layer architectures are also available. The reason is it's not possible to communicate every single data to the application layer, because the amount of data you are collecting, right, not necessary always to the business. Sometimes you have to filter it, you have to pre-process it, and then the desired data only probably you want to communicate. So some local communication, computation has to happen. Then you put it on the servers. Though we have not mentioned in this slide, but we understand there is also a need of security layer, because nowadays even in the devices people are hacking the IoT devices. So the protection, not only in computers, you also have to bring those security concepts in IoT domain also. So if you look at the complete ecosystem of IoT, like I already mentioned with the help of the layers, but if you look at the diagrammatically, let's take for example, some sensor is sensing your blood pressure or some heartbeat and so on. But then that data is locally available, but you have a healthcare sector where the doctor could be anywhere in the world and the doctor wants to analyze the patient's data globally. The patient is carrying the sensor wearable devices, but when the patient is moving, then how do you communicate the data? So the easiest way is use the mobile phone because it has a inbuilt 4G communication or 3G communication. So the device will communicate to the mobile phone with the help of a Bluetooth, and the mobile act as a router access point, will connect to the some gateways, some Wi-Fi communication or some 4G communication, LTE communication. Then it is connected to some data centers, data warehouses, where the analytics takes place. When you have a huge data collection, then you can have your own big data analysis algorithms. Once analysis is done, then services comes into picture. The doctor may predict, the doctor may suggest some services. So it's a business model. Client, right, is communicating to the patient, to the doctor, and diagnosis is happening in real time. So there is a business model is involved here. So this is how the entire IoT ecosystem works. A sensor that is called perception layer, collecting the data, communicating the data with the help of some communication network, data analysis is happening, and then business model. Let us look at the volume of data involved in this domain, IoT applications. Like I started saying, what is minimum system, or the what do you mean by things, that is called devices, or we also called as a edge computing. So these kind of devices, IoT devices, they are billions, maybe trillions. Like I said, the population almost double every few months. They are sensors, they are computational devices, they are communication devices. The next layer in this pyramid is the fog devices, fog nodes. Fog computing could be access points, or they could be routers, right? They could be switches, they could be gateways. They won't be billions, but they may be millions. Because these edge devices, they are might not be directly connected to the internet. Like I said, FASTag on every vehicle might not be connected to internet. It may be connected to a local RFID tag reader, and RF tag reader might be connected to the internet. So like that, in a industry, in a house, in borders, in hill stations, in deserts, in the space, underwater, all remote applications, instead of connecting all the devices to the internet, maybe in a house, all your air conditioners, refrigerators, washing machine, all of them are connected to some local gateway, and that gateway is connected to the internet. So that is called fog nodes or fog computing. It's a router basically. Then comes to the data centers. They're not millions, they may be few thousands at national or international level. All these nodes, finally, the devices are connected to the data centers where the data center could be anywhere in the world. So that's where the Internet of Things comes into picture. Now, in terms of the volume of the data, in a IoT device, in an edge device, it may be smaller in size, maybe a few kilobytes, megabytes. But when it comes to a data center, it could be giga and terabytes of data you can acquire, you can compute, and you can develop your own predictive algorithms. So that's how you can look at as a volume in terms of devices and in terms of communication, that's the bandwidth, and also in terms of the size of the data. So in a IoT infrastructure, you require edge computing, you require fog computing, you also require cloud computing based on your application in terms of maybe a volume. In terms of skill set, you may be a scientist or you may be an engineer. A data scientist is always a hypothesis, right? He comes with a hypothetical models, and then that hypothetical things can be converted into some objectives, and objectives can be implemented with the help of skills like advanced mathematics, advanced statistics, advanced analytics. However, a data engineer's job may be acquiring the data, cleaning the data, processing the data, aggregating the data, and programming the various data models or distributed systems, parallelism, pipelining, and so on. So these are two different kind of skills we expect. As a data scientist, you always talks about the hypothetical models and realization with the help of the advanced mathematics. Whereas an engineer's job is to design, to build, to aggregate, and also program it, the mathematical model given by a data scientist. I hope now you can understand the structure or the architecture of a IoT domain. So what do you expect? You may be a telecommunication engineer because communication is involved, sensors are involved. You may be a computer IT student having a skill set of science background, computer science background, computer engineering background, or the little bit of narrow down branches like IoT, security, data science, artificial intelligence, machine learning streams. So you can find the scope where you may be an expert, maybe in one or two layers, but if you don't understand the other layer, then you are actually not an engineer. You are some commerce arts student. Because we are not talking about computer as an application. We are talking about device, Internet of Things, device as an application. And computation can happen at edge level, fog level, and cloud level. And the data is volume of the data could be few kilobytes, megabytes, or giga or tera petabytes. The kind of skills required could be a philosophical, hypothetical models to convert them into mathematical models, system design, and advanced analysis. At the same time, the engineer's job is for converting those hypothetical models into reality, experimentation, and some implementations. So looking at the minimum three layers, perception layer, network layer, and application layer, while implementing the perception layer, undoubtedly you require to acquire the data in real time. You may require some sensors which will convert your physical parameters into electrical signals. Those electrical signals are converted into data form, numbers. That is the first layer. So the sensors could be, as you know, for distance measurement, it could be a ultrasonic sensor. For a temperature, it would be a thermistor or thermocouples. For a obstacle detectors, it could be a proxy detector, proximity detector. For light, there may be a LDR or a infrared sensors, or like a gas sensors, color sensors. For touch, you have a capacitive sensors, and so on. Like biomedical, we use heartbeat, pulse sensors. So what is your application accordingly, and who is your customer accordingly? You have to choose the sensors, that is called the first layer of your IoT. So once these signals are generated, I hope we can understand that the signals could be one-dimensional signals, the signals could be two-dimensional signals, the signals could be three-dimensional, or the signal could be four-dimensional signals. If you look at the applications, let's say for example, the biomedical sensors, all the sensors, like so far I said, humidity, temperature, pressure, radiation, displacement, all these sensors, including speech, right? They're all one-dimensional signals. because the only in one direction the signal is changing, signal's amplitude is changing. However, if you look at the pictures, images, there you have two variables are changing. In two dimensions, they are changing. Similarly, if you look at the video, then there are three-dimensional signals, three parameters you have to consider. There are four-dimensional signals where along with the three dimensions X, Y, Z, you are also consider the time. They could be a four-dimensional signals. Alright, so that's how you have to use the sensors based on your application, whether they are 1D, 2D, 3D or 4D sensors. Alright, so what is the second layer I said is the communication layer, right? In communication layer, the communication could be different types. Like I said, not necessary that always we are talking about internet. It could be short distance communication like near field communication, RFID, or also a slightly large distance communication like Zigbee, Bluetooth. Today we are also talking about LoRa, where a slightly large distance communication, maybe 15 kilometers, or global communication, right? Like 3G, 4G, 5G, LTE communications, and Wi-Fi communications. So protocols are different types, network protocols. So which protocol to be implemented, that depends on the kind of application you are having. So not necessary that always we are using internet TCP/IP protocol. It could be other protocols also, because sometimes you require local connectivity, local computation. Sometimes you require global communication and global computation. Right. Third is about your computation. When you talk about the computation, that is the CPU, what kind of CPU you would like to deploy in your IoT application? That is based on the size of the data. Artificial intelligence is not new. Artificial intelligence we have discussed in 1970s also, 80s also, 90s also, 2000 also, today also. But the difference is earlier they were limited only conditional statements like if then else is also considered as a artificial intelligence. But today it has gone much, the mathematics has gone much deeper, because the number of parameters, the amount of data which we are computing is much higher than what we used to be. So smartness of any system depends on the number of parameters and the amount of data. When we can say intelligence, intelligence is because of the amount of knowledge it is having. Humans are naturally intelligent because they have acquired the data while growing a small kid to a matured or a senior citizen. For a period of time, they have acquired the data and they have developed the semantics out of it, and they are able to predict, project based on the knowledge they have acquired. And we expect the same things to happen, do it by devices today. So that is where the artificial intelligence comes into picture. Humans are natural and machines are artificial. So let us look at the further types of models, your mathematical models. Based on the amount of data and the, like I said, the parameters, the mathematical models, what we call as a order, order of processing, first order, second order, and so on. People have further classified them to called deep learning, machine learning, and AI. We can see the applications like purchase predictions, speed traffic monitoring systems, Facebook, that is social media applications, and then self-driving cars, robotics applications. So it altogether has become a big data analysis. So where the data itself could be a mining, analytics, analysis, or it's a science. Like I said, the kind of expectations from a data scientist is different and expectations from a data engineer is different. All right, so there are no more only a conditional statements and small data. They are highly complex mathematical models and huge data. That is where this edge computing, fog computing, cloud computing comes into picture based on your mathematical model and the size of the data, where to implement these DL, ML, AI models and the data visualization, right? Analysis, analytics, visualization. How will you do that? All right, so that's how the whole classification is about in IoT domain, which platform to choose. That is about the computational devices. Quickly, if you look at the applications, since you are looking for some application development, you can also think of fundamental research, but let's see, we are talking about applied science. So if you see mechanical engineering, for example, mechanical applications like transportation or the vehicles, right? Traditionally, vehicles are IC engines, but now today we are talking about electrical motors. Including refrigerators, air conditioner is supposed to be mechanical engineering, but now there's a lot of software, hardware is fabricated in these systems also. So now it is like a, say, entire mechanical thing, from like health monitoring system like CNC machines, turbines, windmills, air conditioners, electrical vehicles, smart manufacturing, automotive, supply chains in big e-retail companies like Amazon, Flipkart, and so on. Windmills, hydrothermal, these are all huge amount of data collection, data analysis, business model is involved. It's a $1 billion industry. So don't look at this as a mechanical or a electrical or a electronics or a computer science. It is a combination. Every layer in IoT, in this OSI model, every layer requires a different kind of expertise. So you are supposed to have these skills in make using of this expertise to build the application. Otherwise, if you develop the mental blocks, like I don't understand this, I don't understand this, I am not belongs to this, then you are a commerce arts student. You are not an engineer. Engineering is all about the complete ecosystem, right? You are a creator, you are not a labor. A labor's job is only know one skill, lifelong repeat that skill. That's a labor. It's okay up to ITI diploma, some extent diploma, I would say, is okay as a skilled labor. But an engineer is supposed to be a creator, developer, designer, innovator. So naturally, you should understand the complete ecosystem of that particular application. Like I said, engineering is all about applications of science. So if you do not want to understand the science, then you are a labor, right? All right, so that's the thing about a mechanical application because this is multidisciplinary in nature. Like I said, for example, health monitoring of a machine, like a CNC machine. A CNC machine may be having some motor drives, actuators, sensors. So they need to be connected, communication, finally to the data center. Like say, for example, nowadays, even the flights or the drones, all these CNC machines, like already mentioned, they're all connected to the data centers. All the multinational companies, all the machines are communicating, including your own refrigerator, air conditioner, is communicating to the data centers. So when you claim the performance, when you claim the insurance of your vehicles or your machines, the company is already having the data of that particular system and they analyze the data why that machine is failed. So your false claims will come to know easily because 24 by 7 they are monitoring those sophisticated machines. So that is the meaning of health monitoring of the machines. I have taken this case study which we see as a mechanical things, right? Forget about electrical electronics. Even if you look at the civil and mechanical also, you could see what is the significance of a computer science, computer graduate engineer. I hope now we can understand. I have a lot of videos about the Boston robotics and all those, right? The multinational companies and world-class universities, how they are working on the robots, robotic design, robotic program, robotic intelligence, like Sony and all, they also have their own products. What happens is that they are standalone systems first. They are moving without any 230 volts connectivity, cardless systems. What does it mean? They are battery operated systems sometimes. Sometimes they are moving, rolling, lifting, right? Rotating, freedom of access 1D, 2D, 3D, 4D, 5D, right? Axis of rotation 180 degrees, 90 degrees, 360 degrees. They may looks like a human, like a humanoids, or they may not be like in this figure, only one single arm, two arms, three arms, four arms, based on the application. But smart systems, because lot of data they are acquiring and they are predicting before they make a next movement. The entire industry, right from simple pharmaceutical companies to mobile manufacturers, the vehicles manufacturing is happening, including Boeing, right? Airbus manufacturing is happening with the help of the machines. So imagine how AI has penetrated, which is replacing the human beings in the manufacturing sector. So now when I say deep learning, machine learning, artificial intelligence, it's not limited to a data center where the stock market or a financial sector sort of a thing. They are there in the machines. Even a simple attendance taking machine, which is costing hardly 5,000 rupees, which will recognize your face, your iris, your finger, is a smart system. So smartness is everywhere to the those guided missiles and so on. I hope now you can understand the significance of computer science, computer engineering, plus the other domains, how important in various industrial consumer applications. Today, we are able to track the vehicles, track the people, track the products globally, right? Entire logistics, when we are doing e-commerce, right? Every single order, we are able to track it from the delivery to the warehouses because every product has a unique tags, unique IDs, and they are connected to the local servers, then to the data centers, and the data is available globally, where a customer is able to monitor these things. So hope you can understand the amount of computation, communication, sensing is involved in this trillion-dollar industry. Most of the IT sector jobs are in service sector. 80% of the jobs are in service sector. So if you don't understand who is your customer, what are the applications, then what will you do with the help of just a degree or a programmer? Because your applications are everywhere. You need to understand, right? For example, power electronics, you need to understand what are their parameters. Healthcare sector, you need to understand their parameters. Agriculture sector, you need to understand their parameters. Mechanical engineering, you need to understand their parameters. Civil, you need to understand their parameters. So if you don't understand their parameters and how to sense the data, then if you assume the data, then you are not an engineer. Data has to acquire, you have to develop your own hypothetical models, then rest of the business is okay, we can understand, then MBA and all comes into picture. But never ever assume the bottom layers. So like I said, smart energy is again a, I'm sure you understand, it's a $1 billion business of electricity generation to electricity distribution till the consumer where the electricity meter is connected. Now, if you look at the, the amount of power generated, it's not generated because of the one power station. It could be a windmills, it could be PV panels, or it could be diesel generators, or it could be hydropower, it could be nuclear power, and so on. When so many sources are contributing to energy generation, look at the volume of the data. You have to collect it in real time, process it, predict it, the amount of power is generated at any given point of time in 24 by 7, 365 days. Every second you have to sense the data, analyze the data. Similar the other way around. The load. How many devices are connected on the power system? Right from simple bulb to the air conditioners, refrigerators, industry, CNC machines, welding machines, big loads like trains. When such a highly dynamic loads are connected, at which time, which system is on, how to distribute the power, which is consuming how much power, how to take care of the balancing of the supply and the demand is a real classical example of a for a data scientist and data engineer. I hope now you can understand that computer science, computer engineering is not just data analysis. You also need to understand from where the data is coming from. And if you assume that, then like I said several times, then it's a just a commerce student's job of only visualizing the data or business models. So is the fleet management. All right. I hope you can understand how these smartphones, smart watches, how many sensors are there in every phone, every watch, Fitbit watches. A watch is supposed to cost you hardly 100 and 200 rupees. Today is costing 10 to 20,000 rupees. A mobile is supposed to cost a 500 rupees, is also costing 1.5 lakhs. So look at the business models, the apps, the sensors, the customers, and their applications. So everything is lead to the smartness, smartphones, smartness because of the algorithms and sensors in it. Okay, so far we have discussed about the lower layers of IoT. Now let us look at the highest layer, that is the application layer and the business models. The highest layer is all about the service providers, IoT platforms. We know maximum employment is happening at the highest level because, like I said, 80% of your business is a service sector. So naturally, you require a huge manpower to build the applications. When you are developing the application, you may require, every customer may require their own dashboards. So when you build a dashboard, naturally you require some three services already said. Data as a service, right? Device as a service, platform as a service. So the popular companies like Amazon, Microsoft, Google, ThinkWorks, IBM, Cisco, HP, Siemens, Bosch, these companies have heavily invested in these platforms, commercial platforms. But then again, this is for IoT applications. That means you need to understand who is your customer, what are their features. Accordingly, you can design a dashboard for them. Though designing a dashboard won't take much time, but then anybody can do that if you understand the platform. But if you want to provide the security, if you want to provide the performance, then you need to understand every single layer. So how to choose a platform? When you choose a platform, It depends on who is your customer, because the customer is looking for in future maybe scaling up his business. Like say for example, today I have 1,000 customers because I have 1,000 clients, 1,000 schools. But eventually I may expand, no, at state level, national level, international level. So my customer may increase from 1,000 to 10,000, a lakh of people. So how do I scale my platform, IoT platform? Then about the reliability. If your customer is from power sector, if your customer is from healthcare sector, is at most reliability need to be provided, because it's a life and death. It's not a, for example, if you are in a media like social media, right, or gaming, some failure of a network, failure of the some samples, nobody will die. Let's say if some frames are missed, you will not come to know in the audio or video. You're still watching your movie, you are still playing the games, nothing will happen. But in case of a healthcare, in case of a power sector, there may be entire system may collapse, the patient may die. That's the reliability one has to think of while choosing the IoT platform. I mean to say all layers, not just the top layer. Then customization. Why I have started this training programs or this entire ecosystem, my company itself, is because this is not a general purpose system. It's not a computer where the whole world is having one single model. Absolutely no. It is a application specific, like I was saying last 1.5 hours. Customization. You have to look at the customer. Every air conditioner, refrigerator, two-wheelers, four-wheelers, drones, pilot, these autopilot systems, your smartwatches, mobile phone. You look at every product. Every product is specially designed for a specific application. So that is the beauty of hardware, software design, partitioning and design. So customization. While choosing the platform, you need to look at my customers are different. Can I able to customize? Let's say Microsoft operating system. It's not customized. The whole world is using one single operating system. If anybody attacks, the whole world is getting affected. That's the problem with a general purpose system. In customization, why do they affect? Because every hardware is different, every operating system is different, every application program is different. So it won't affect. All right. So look at the kind of operations you require. The protocols need to be implemented, the hardware agnostic, the cloud agnostic, the support you are supposed to provide, and the architecture technology stack, security, some of the applications, at most important, finally cost. If you look at the consumer sector, they are very, very cost sensitive. But if you look at the defense healthcare sector, probably they won't look at the cost, but security, reliability is at most important. So while choosing the platform, at least these parameters you have to consider. So if you are doing some work, mini projects, major projects, even the PhD or product development, look at the taxonomy of IoT technologies, where you can contribute. Would you like to contribute in the perception layer? Like you can see various types of sensors, right? From healthcare, environment, chemical, because we have so many customers. We have a inquiry from pharmaceutical companies or the colleges which are in the pharmacy sector. They want IoT solutions. Similarly, I already said power sector and so on. So look at the customers accordingly. The perception layer you have to build. If you look at the mobile phones, it's a huge business. Then comes to pre-processing. That's called edge or fog computing. So if you want to do your project or research, again, you can do it at the computational level, the architecture, right? Then comes to the communication. That's the second layer. What kind of communication protocols you would like to use, short distance, long distance, or the networks, right? Various wireless sensor network protocols you want to implement, like Zigbee, Bluetooth, Wi-Fi, and so on, or some routing protocols you want to work. So that's about the communication. But finally, it's about the services, software services, right? Applications. So this already said, like, look at the customers like smart transportation or the entertainment, home automations, healthcare sectors, agriculture sectors, energy. So look at the applications accordingly. You can work on the work for the business models. That's where information technology comes into picture. IT, OT, operational technology, and information technology comes into picture at the higher abstraction layers. Okay, so let me quickly classify the applications. Your application, look at any IoT application, it may have the following components. First, every application may have a device. A device, like I said, thinks. A device means it has the identification, it has the ability for sensing, actuating, monitoring, and so on. Then your application may have some resources like software as a resources, processing as a resources, storing as a resources, and so on. Then your application may have some controller, control as a services, right? Like web services or communicating the data and so on. Then the database itself is another component. Sometimes you require a local database like edge computing, or sometimes you require a global database like a cloud storage, right? So it's about the database in your IoT application. Then the application layer, web services. So one of the, if you are connected to the internet protocols, then web services like HTTP protocol, right, or WebSocket protocols, and so on, because you want to be part of the global network if your IoT demands. The another component is analysis. Once you acquire the data, then probably you have your own mathematical models. That's where the data science comes into picture. So what is your, like I said, artificial intelligence, machine learning, deep learning, some analysis you would like to do it on the data. So they are mathematical models, that is the libraries. Then the application itself. Finally, application provides some interface to the users, right? So which application demands what kind of interface? Either it could be a simple LED buzzer to some dashboards and so on. So based on these many components, let us classify various IoT applications. Which application demands what kind of devices? So the first level of the application, if you look at the kind of components which are used, there is, let's say, for example, some user interface, then the device, like I explained about what are these components, some resources and a controller, some database is there, local database, and finally you are connected to the internet through either reset or REST or WebSocket protocols, and there may be some application. What you can see in level 1 is a single node, only one node, one IoT node, which is implementing all these, make using of all these components. So what is this? This is a system has a single node or a device that performs sensing, actuating, storing, analysis of a host application. It hosts the application in single node. Systems are suitable for modeling low cost, low complexity solutions where the data involved is not big and the data analysis requirements are not computationally intensive. Let's say, for example, you want to switch on a LED bulb or you want to switch on a refrigerator or a air conditioner remotely. So there is an app is there on your mobile phone connected to the internet. You want to operate it. So there is no great mathematics here, no computationally intensive. A single node can takes care of sensing, communication, computation. Even if a small data is there, it can store it within the device. Finally, what you are looking for is maybe a temperature of a air conditioner or a color of a LED bulb and so on. So such kind of applications, IoT applications, are called level 1 applications. In level 2 application, if you see more or less single node, however, you will find that the database is not local. It is there on the cloud platform. However, the components are same, like device are used, resources are there, controller is there. But then after that, the communication, the data storage is happening at some cloud platform, cloud storage. So where will you find such kind of applications? Let's say surveillance camera. So if you are acquiring a image or video, audio in real time, you cannot store the data in a device. The device might not be having mega or giga terabytes of storage. You have to communicate somewhere, you have to store it, that to 24/7. However, some sort of a analysis can happen locally, because if it is a suspicious thing, then only I will acquire the data, otherwise no. So that kind of algorithm you can do that, so that every single frame you need not acquire and communicate. All right. So level 2 systems has a single node, performs single or actuation sort of a local analysis. Data is stored in the cloud and the application usually cloud based. Systems are suitable for solutions where data involved is big. However, the primary analysis requirement is not computationally intensive and can be done locally. So the primary analysis is happening locally, but however, the volume of the data is big, then you can put the data on the cloud storage. So in short, it is a cloud-based application. If you look at the application type 3, diagrammatically more or less same as level 2, where device, resource, controller is local. Data storage and is happening at the cloud level. But one slight difference is here. It's not only cloud storage, even analysis is happening at the cloud platform. So you don't need to do any local analysis. It's a global. On the cloud platform, you are doing the analysis. So which kind of applications you require? A computational intensive. What do you mean by computational intensive? Like I said, AI, ML, right, deep learning, all these things are computational intensive because they talk about always big data. See, whether it is a right a small prediction to be done, I can do it at local level. But if it is a right a prediction which is having some which requires some knowledge, then the small data is not enough. Like even for example, today we talk about weather monitoring. Weather monitoring, even today, some of the expert systems are failing. Their prediction is not correct. Similarly, human behavior, right? Whether the election, in the election, who is going to win? Most of the predictions are getting failed, and so on. So the mathematical models which are built, they have to be built on a huge data on cloud platforms. So level 3 systems are single node, data is stored and analyzed on the cloud platform, and the applications are cloud based. Systems are suitable for solutions where the data involved is big and the data analysis requires computationally intensive. All right, so that's about the level 3. Level 4 is not about one single node. It could be multiple nodes, multiple IoT devices. It is have same capabilities like devices, device resource controller. However, it's a network and they are connected to either through REST or WebSocket to the internet connectivity. The data is stored on the cloud storage. Analytics happens on the cloud side. However, it cannot be done by using one single node. The data collection happens from the multiple resources. So that's why you also require an observer node on the local side as well as on the cloud side, so that at any given point of time you need to monitor which node is doing what kind of a task, because you are distributing the task. It's a multitasking environment and every node might have some work to be done. So some sort of a routing you have to do among the nodes. So some sort of a monitoring performance of the local, and also similarly the some managerial things also happens on the cloud platform. So systems are having multiple nodes, do local analysis, data is stored in the cloud and application is cloud based. It contains local and cloud based observer nodes which can subscribe to and receive information collected on the cloud platforms. Systems are suitable for solutions where multiple nodes are required. The data involved is big and the data analysis requirements are computationally intensive. So why do you want multiple nodes? Let's say I want to monitor various wind turbines. So one wind turbine to other wind turbine, the distance is not close, not less than at least tens of meters. So naturally that cannot be done by one node. Look at the concentrated solar power plants. They are spread across the number of acres of land. Look at the PV panels. Number of acres of land they are spread. Look at the airports, not less than 500 to 1000 acres of land. Look at the borders, hundreds of kilometers. Look at the agriculture fields, hundreds of kilometers. So when you are these the space applications, underwater applications. So such kind of applications, when you are doing, it cannot be done by one node. Every node, for example, in an aircraft, right, is such a huge thing. Every node has some purpose. So, or the in navy ships. So it is a network of the devices first, and then they are connected to some routers, and then data collection, data analysis happens at the cloud platform level, right? Level 5. In level 5 application, if you look at level 4, there is a another node called coordinator. So if you see carefully, the the first node, second node are not directly connected to the web services. They are connected to, there is another node we called as a coordinator device, but the first two, therefore the level 5 system, so every endpoint is not connected to the web services. The controller coordinator will decide first acquiring the data and some local analysis, and then finally the coordinator will pass it on the data to the cloud platform. So systems have multiple end nodes and one coordinator. The end nodes that perform sensing and actuation. They're responsible for sensing and actuation endpoints. Coordinator node collects the data from the end nodes and sends to the cloud platform. Data is stored and analyzed in the cloud, and application is on cloud platform. Level 5 systems are suitable for solutions based on wireless censored networks in which the data is involved, is big, and the analysis requirements are computationally intensive. Actually, there is a good amount of research is happening, and in the past also is done in what is called wireless sensor networks. So networking of the nodes. However, not necessary that every node is connected to the web services. There is a local coordinator and these endpoints communicated to the coordinator. So that kind of a networking, right, like a mesh network or maybe star network and so on. There are several types of protocols which are popular in this kind of a uh, coordinator and that's called router and endpoints communication networks called wireless sensor networks. Level 6. Level 6 is a much complicated communication network system. As you can see, the system has multiple monitoring nodes and there is a centralized controller. The centralized controller, maybe you can say fog device, which is communicating to the every node, and every node has the ability to communicate to the web services, right? So they are independent in nature. In this case, they are not communicating to the some local coordinator the complete data, and the coordinator is connected to the web services. No, not like level 5. Level 6 is they are independent. However, centralized controller is controlling which node to participate in the web services. Otherwise, right, it is a multiple independent end nodes that perform sensing and actuation and sends the data to the cloud platform. Data is stored in the cloud and application is cloud. The analytic component analyzes the data and stores the result in the cloud database. The results are visualized with the cloud-based application. The centralized controller is aware of the status of all the end nodes and sends control commands to the nodes. So this is how, irrespective of whatever your application may be, the components are more or less same. However, whether they are local or they are at the cloud level, that makes the difference. That depends on the complexity of the application, the amount of data involved, and the amount of computation which is involved. Accordingly, the applications are classified. All right, so that's about the various IoT applications and their classification.